This is chapter 8, arithmetic sequence. And this is how we're going to present this 8A lesson with an example of a theater that has 10 seats. A theater has 10 seats in the first row, 12 seats in the second, 14 in the third, on and on and on and on. How many seats are there in the last row if the theater has 30 rows in total? All right. There's the theater right there. And down at the bottom is the first row. And there's 10 seats. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10. In the second row, there's 12. In the third, 14. In the fourth, whatever, I don't know, whatever it is, it's adding 2. How many are there in the 30th row? Somebody's saying, what do you think it is? 60. Somebody's saying 60. No, maybe. Somebody else, a guess, quick. No other guesses? Okay. So we could go in and do it like, say that there is 10 here, and then there's 12, and there's 14 and 16. But it seems too tedious to be doing it like that. Is there a much faster way, a higher level? Yes, there is. Let's do it. Okay, go ahead and write this down. And the way we do it is we do it like this. The amount, A stands for the amount of seats, I guess. A stands for the amount of seats in the nth row. We'll put a little n there. So it's a letter A with a little n in the nth row. So the amount of seats in the nth row, this seems to be continually being added by 2 to get the next one. You see that there's 10, and to get the other one is 12. So we're adding 2 to the previous to get the next one. So A sub n will equal to the amount of seats. We need a beginning. How many seats are there in the first row? 10. And there's 10. We'll put that in a minute. And then, so we're coming up. There is 10 there. And then, to get the amount of seats in the subsequent rows, would be the n, because I already counted, I'm already saying that there's 10 in the first row. So how many will be in the next row would be, subtract 1 because I already counted this one, times the common difference, whatever I'm adding. So I'm going to tell you that I came up with a formula. I'm going to put in the numbers in a minute, but this is going to work. I'm saying that it will work. Okay, so now let's go ahead and plug in some numbers. So for any, this is a formula, that's why we're going to leave it as the amount of seats in any row that hopefully we'll be using for 30th row in a minute. So the amount of seats in the nth row will equal to the amount of seats in the first row. The amount of seats in the first row. How many seats are there in the first row? 10. Plus, leave this as a variable because we need this as a variable, n, for any nth row, times the common difference. So how much are we adding to the previous one to get the next one? So it's 2. So I'm saying that this is a formula to be getting all these amount of seats in any kind of row. So this would work. We could almost be done with this, but we simplify it some more. Let me simplify it some more. How do you simplify it some more? By multiplying it in. This right here. And so this is going to continue on. A sub n is equal to 10 plus 2 times n is 2n. And 2 times negative 1 is negative 2. And simplify it some more by saying that A sub n is equal to 2n. Leave it alone, 2n. And 10 take away 2 is what? Plus 8. Plus 8. Now, I am saying that this is the formula to getting the amount of seats in any row of this sequence. Let me test it for A1. The amount of seats in row 1, first row, there should be 10. So when I go here and I say A sub n is 1, A1 is going to equal to 2 times n is 1. What is 2 times 1? 2. And what is 2 plus 8? 10. So it works out. So it's working out. Will it work for the next one? Yes, it will. If I say in the second row, n is 2, in the second row, how many seats are there in the second row? How many seats are there? 12. So if I go A sub 2, 2 times 2 is 4. What's 4 plus 8? 4. So this formula works. That I don't need to be going here and doing, it's 10, 12. I can directly go to the 30th row. The 30th row by plugging in A sub 30. So the amount of seats in the 30th row will equal to 2 times 30, n is 30, plus 8. So what is 2 times 30? Plus it's 68. 68. So the amount of seats in the 30th row is 68. I would have thought it was 70, and I would have been wrong because it really is 68. And that is the lesson for today. That's the big idea. In arithmetic sequence, we'll have this formula. Well, not that one, but this one. This is the formula you need to know for today. A sub n equals the amount of seats in the first row plus n minus 1 times d. Okay, that is it. Let's go on to doing some other problems. That's problem number 1, I guess. Problem number 2. What actually is an arithmetic sequence? An arithmetic sequence is when to get the next number in a sequence, you only have to add or subtract a constant number. So in an arithmetic sequence, the difference between consecutive terms is constant. Here's an example. A savings account where you deposit a constant amount of each week. So you have a savings account, and so you started working, and so next week you get your first paycheck, and you say, hey, you know what? Can you just deduct this amount, like $50, and put it in a savings account? So every week they take out 50, 50, 50, and that is a constant amount. That is. Yeah. All right, let's go problem 2. Tell whether the sequence is arithmetic. If it is arithmetic, find the next 5 terms of the sequence. So the formula for an arithmetic sequence is A sub n is equal to the amount of, you have to have a beginning term amount in, and then you're going to have plus n minus 1 times d, n minus 1. So you do have to have a beginning term, but the most important will be a common difference. A common difference, which is either added a common amount or a subtracted common amount. It is a given that we will have in any sequence we have an A1. We do have A1. So the problem is, for this particular one, do we have a common difference? Is there a common difference? So what is the common difference? What the common difference is that we're adding how much? 10, you said? 100 plus 10 is what? 110. And 110 plus 10 is what? What's 110 plus 10? 120. It makes sense that it is arithmetic. So yes, it is. So let's get the next 5 terms. What's the next term? 130? 140? 150? Okay. This is, this is taught in Algebra 1. I know it is 100% for sure. That's way too easy. This is too easy. Let's go. Well, all right, let's go to number 3. I'm moving on fast. Number 3, let's go. Find the first 5 terms. It's already telling you it is arithmetic. Find the first 5 terms of the arithmetic sequence described here, where they're telling you that A1 is 10 with the common difference of 5. Just what's A1? 10? I was gonna say it's a good steak sauce, but some people like A1. A little bit? A1 sauce? So A1 is 10. And you adding 5 to get the next one and to get the 15? 25? This is too easy again. This is A1 is 10, and to that 10 you're adding that common difference of 5. 5 plus 10 is 15. 15 plus 5 is 20. Okay, too easy. Let's go next. All right. Next. Number 4. Tell whether each sequence is arithmetic. If it is, find the rule for the nth term. So we got a little bit of a little weird numbered sequence here. Not as simple as 5, 10, 15, 20. So for an arithmetic sequence, 2 things you must have. The first one's easy. Well, you got to have a sequence in the sequence. You have an A1. You do have an A1. That's easy. For any sequence, you have a beginning number first. So the A1 is already, we got it. The problem will be, does it have a common difference? Does it have a common difference? This particular one. Yes or no? And the answer is yes. What is it? Plus 7 to each to get the next one. So it's a yes, where we have A1 is 5. And the common difference is 7, because 5 plus 7, 12. 12 plus 7, 19. 19 plus 7, 26. 26 plus 7 is 33. On. So the common difference is 7. So the formula is up there in the corner. A sub n equals A1 plus n minus 1 times d, where we do have A1, and A1 is 5, plus, we don't put a number for n, that's going to stay as a variable, take away 1, times the common difference. Yes. Okay. Trinity, you go home or around the way. Here's the homework. N minus 1 times the common difference. D, what's common difference? That would be that is okay. But we can simplify it some more. That should work. But let's simplify it some more. Multiply. A sub n equals 5 plus 7 times n. 7 times negative 1. Oh, we're 7. Okay? So A sub n is equal to 7n. Is there one person I'm going to pick on in this class? Hold on here. I got 2 that I could pick on. Denise. What's 5 minus 7? And let me write it down like this for you. Be quiet, everybody. 5 minus 7. Loud. What? Five. Oh, what the heck did I? Yeah. Stupid. I'm trying to mess you up. Sorry about that. 5 minus 7. But well, you were doing this one because 5 plus 7 is 12. 5 minus 7. Somebody else said 2. The answer is negative 2. Look. I did this in my other class where like some people are like is it 2? Is it 2? Look how it's not gonna make sense if you think it's 2. If you think it's 2, you're like, I think it's 2. Okay, let's put 2. Let's put 2. So now, let's test it, and there's going to be a problem here. Why is there going to be a problem? Because A1 should be what, everybody? A1 should be 5. Yes or no? So when I plug it in, AN is 1, and I go 7, N is 1, and then I add 2. 7 times 1 is what? 7. And the 7 plus 2 is what? No. Is that what I got here? Is that what I should get? So there is either everything wrong I'm doing, or I just don't know how to subtract and add numbers. And I'm going to go with I don't know how to subtract and add numbers. What's 5 minus 7? Negative 2? Yes? So when I go back here, it better be minus 2. And so when I try to test this, and does it work? Let's go. Let's try to do what? What is this one? Which one is this one in the sequence? A1, A2, A3, A what? A4, yes? So when I go here, I'm going to go A4. A4 is equal to 7 times 4 minus 2. What is 7 times 4? 28. And what is 28 minus 2? 26. Is that what we're supposed to get? Okay. So AN equals 5 plus N minus 1. Distribute. You get that. You do the math because you know how to do the math correctly. You get that? All right. Let's move on. So that this is the formula. for that sequence. Is this a arithmetic sequence and somebody's already saying what?
No.
Why not?
It has a difference. 2 plus 3.
So this one is a plus 3, this one's a plus 3, and this is a plus what?
6.
So it's supposed to be plus 3, plus 3, plus 3, plus 3, plus 3. That's a no. Not arithmetic. Let's go to C. It either has to be add a constant amount to get the next number, or subtract a constant amount to get the next number. Either add or subtract. Is this an arithmetic sequence, yes or no? And the answer is yes. What are we doing to get the next number? We're adding a what? Negative 6. Negative 1 plus negative 6 is negative 7. Add a negative 6. What's negative 7 plus negative 6? Negative 13. Okay, it is. So this is, so A1 is negative 1. D is the number that we're subtracting. What was it? Negative 6. So you need your A1, you need a D, and then you plug it in, and it's going to be AN equals negative 1, which is A1, plus N minus 1 times negative 6. Distribute A sub N equals negative 1 negative 6N plus 6. A sub N equals, let's put that negative 6N first. What's negative 1 plus 6? 5. Positive 5. And that should be okay again. Because negative 6 times, let's test 1. Negative 6 times 1 is negative 6, plus 5 is negative 1. Let's go to D. Tell whether each sequence is arithmetic. If it is, find the rule for the nth term.
No.
And why do you say no? Somebody.
-4, then -2, then -1.
Oh, you're directly testing that is there a constant, and that is correct. But there is a sequence to it, no?
Yeah.
But it's not arithmetic. We're dividing by 2, no? You see, dividing? You divide by 2, divided by 2, and divided by 2. But that is not arithmetic. That would be something else. And the last problem for today. Here we go. Last problem. Write a rule. Okay, this is going to be on the test. So make sure you know how to do this. This is on the test. Whenever we take that test, write a rule for the nth term of the arithmetic sequence. If you're given A7 is 17, A26 is 93. So you are given two numbers in the sequence. You don't have A1. A1, A2, A3, A4, A5, don't do this, A6, A1, A2, A3, A4, A5, A6, A7. You have A7, and then you have A26, but you don't have A1, and you don't know what the common difference is. So we got a problem. This is a problem. So to find a rule for the sequence, it is to fit A sub n equals A sub 1 plus n minus 1 times d. And you need to know what A1 is, and you need to know what D is. So we got two problems. If there is some way to get one of those numbers of the letters, A1 or D, then we can solve it quickly. And since this is saying that it is arithmetic, arithmetic means that it's linear. This is a line. And when it's a line, it has a slope. And when it has a slope, then between any 2 points, you can get the slope of a line if you have 2 points. So we're going to go ahead and use that idea of finding a slope. So actually, this common difference in reality is the slope of a line. So we can say that D is the slope of these 2 points. D is equal to M. For M stands for slope. Where you, for the top, is the difference of how many seats there are in those given rows. If we go back to talking about what is that we're talking about? A theater. Yes, it was a theater. So the difference in the number of seats, and then at the bottom, the rows. Which row is it? So the outputs are the seats. So let's go like this. 93 minus 17. 93 minus 17. And then we're going to subtract the row numbers. 26 minus 7. What's 93 minus 17? Anybody? What's 93 minus 17?
76.
76. And what is 26 minus 7? What's 26 minus 7? 19. And what is 76 divided by 19? What's 76 minus divided by 19? What? Somebody say 4? All right, so we have found that the common difference is 4. So we can plug in here, this D is 4. So now that we know D is 4, we only need to figure out what A1 is. So how are we going to find A1? Use one of these given points to find A1. And that's what I'm going to do. I'm going to go ahead and use A and A7, because we do know that A7 is 17. So A7 is equal to A1 that I don't know, that's what I'm trying to get, plus, what do I plug in for N? 7 minus 1 times the common difference that we found out already.
4.
That's 4. And it has to equal to what A7 is. What is A7? 17. A7 17. And now we can solve for A1, because all we needed A1 is D, and also D. So A1, bring it down. What's 7 minus 1?
6.
And what's 6 times 4? How do I get the A1 by itself?
Subtract 34.
A1 equals what?
Negative 7.
Negative 7? Negative 7. We have found our A1 and our common difference. We plug them in, and we have found the rule. So we can go here. Let me go here. Use a different color back. So this is going to be what? A sub n equals A1 is negative 7 plus n minus 1 times the common difference of 4. Multiply it in. We're going to get A sub n equals negative 7 for n minus 4. For n minus 4. A sub n equals 4n. What's negative 7 minus 4? Negative 11. Negative 11, and we are done. That is it. How do I know that it works? Let me test it. A7 better get 17. A7, A sub 7. What is 4 times 7? 4 times 7 is 28. What's 28 minus 11? What's 28 minus 11?
17.
Did it work? That is it for today. We are done.